Hello students, welcome back to Turito's live classes. How are you all doing? I hope you are doing great. So students, we have started our second chapter for grade 9th. Okay, so the name of the chapter is what? Is matter around us pure? We are trying to find an answer for this question. The matter which is there in our surrounding, is it really pure? So yes, that's how we have started with few topics such as quickly let's try to understand what are those topics which we have covered in the last session. Okay, so we understood about the classification of matter, right? We talked about that matter is classified in two ways. Come on, quickly tell me what are the two different or types of classification which matter has. Of course, physical and chemical classification of matter, which we have studied thoroughly. Okay, so physical classification is based on what? Physical properties of matter, the properties which we are able to see, which we are able to observe or measure, can be considered as physical properties, and based on these properties we are having physical classification of matter. Okay, so which property did we consider? We considered states of matter, right? So based on this, how many states of matter we have studied? Try to recall. We have studied about solid, then liquid, okay, then gaseous substances, then also we talked about plasma a little bit and Bose-Einstein condensate, if you all able to recall. Actually, we have covered this two fourth and fifth state in chapter number 1, that is matter around us. But I am just asking, are you all able to recall? Okay, so this is states of matter is a physical property, and based on this property, we are having different states of matter. We have studied about the structural arrangement of these different states of matter. Moving ahead, we are having second classification of matter, which is what? Chemical classification of matter. Now, physical classification is based on physical properties. Likewise, we can say that chemical classification is based on what? Chemical properties. Now, quickly tell me, what do you mean by chemical properties of any matter? Properties which we are not able to observe. Something reverts to physical properties. Now, to understand what that matter has, we will have to see inside the matter, right? So, like, what is the chemical composition, how that matter is react, okay, how what is the reactivity of that matter, okay, what is the chemical nature of that matter, either acidic, basic, neutral, etc. Okay, so these were some properties which we termed as what? Chemical properties, correct? And based on this, we are having chemical classification. Students, we have studied about the chemical classification, which is based on what? Chemical composition, chemical composition of matter. Okay, so in that we talked about purity of matter. Okay, so what do you mean by purity? We eat pure substances, right? We need pure ghee, we need pure milk, pure water. So my question was, do these all substances, are they really pure? Yes, they are, and that's why we are consuming it, right? So for common man or for people like us, it is very obvious that we consider these different food items are pure, and that's why we eat them, we consume them, right? But when we are going to see this purity, definition of purity from a scientist point of view or a chemist point of view, he has something different definition for pure substances. Okay, so based on that scientific definition of purity, we have classified matter into two categories. There we discussed about what? Pure substances. We talked about pure substances, and the next one was mixture, or I can say impure substance. Okay, so impure substance has its specific name, is nothing but mixture. Okay, so this is what is a chemical classification, which we discussed in the last class. So pure substances are further divided into what? Elements, right? And next is what? Compounds. These are all pure substances or further categories of pure substances, correct? We studied about elements such as what? Hydrogen, element, sodium, oxygen, nitrogen, iron, aurum, Ag, Au. These are some elements. Okay, so these are pure. Then we actually just started with the next term, that is what? Compounds. In today's class, we are going to understand what compounds are. What are those properties these compounds have, and why are we even them calling as compound. Okay, so that will be our learning object for the day. Then of course we are going to learn about mixtures. Okay, so in elements, I hope you all are able to recall that elements are further classified into 3 categories, and these categories were metals, metalloids and non-metals. Okay, so here I told you that this is what is a periodic table, where we have arranged all the metals, non-metals or metalloids, or in one single word I can say that all the elements are arranged in a certain manner in this table. This is what we called as a periodic table. Now what periodic table is, how it looks like, and that extra study about periodic table we are going to cover in the next year. Okay, we are having a separate chapter. There we are going to understand each and every part of this periodic table. So point here is that be it metals, non-metals, metalloids, whatever the elements we have kept all the elements in this periodic table. Okay, so we have studied about the properties which are possessed by metals. Are you all able to recall? We have seen these images also. See, this is what is a sodium, a soft metal. Okay, this is like an exception. Sodium, potassium, we can cut the metal with the knife, they are that soft. Okay, and though we say they are hard. Okay, so these are some exceptions. Just have a look at these metals. Then we talked about what? Non-metal. So non-metal such as carbon, phosphorus, sulfur, nitrogen, oxygen. Okay, so these are few examples of non-metals, and we have seen some properties of non-metals. Okay, so they are non-lustrous, we see they are having variety of colors, they are not good conductors of heat or electricity. Okay, so again we have studied about that they are non-sonorous. Okay, so these are some properties, and followed by, of course, these were some examples, correct? So these are some examples of non-metals. Moving ahead, we talked about the third category of element, where we have discussed about what? Metalloids. So students, try to understand, in the universe there are some elements, they are going to, under favorable condition, they are going to act either like non-metal or metal. That means they possess both of these like properties of these 2 different types of elements in one element. I mean, suppose we are having a metalloid, I am having a metal, and I am having what? Non-metal. And I am saying that X is a metal which shows properties of metals, or it shows properties of non-metals too in some certain favorable conditions. Okay, so what do we call this substance as? Metal or non-metal? So we have a term called as what? Metalloids. What do we call it as? Metalloids. So we have seen some examples of metalloids: boron, silicon, arsenic. Okay, so these are some images of metalloids. Just have a look. Boron, silicon, germanium, tellurium, then antimony, we are having arsenic. Okay, so these are some metalloids which have a huge application in semiconduction. Okay, so where do we use them, and what are their application? It's a further complicated part which we are not going to cover right now, but try to understand there is a different category of elements available in the universe, and that is what we termed as metalloids. All right. Okay. Then yes, this is what is our today's learning objective. In today's class, we are going to cover each and everything, or each and every point which is related to compounds. Are you all ready? So far we have revised the first session of the chapter Is Matter Around Us Pure, and I hope there is no doubt so far. Okay, shall we move towards compound now? All right. So first of all, try to understand compounds are what? They are pure substances. They are pure substances. Quickly tell me, how do we define pure substances? So pure substances are nothing but the substances which are made up of similar kind, or they are having same type of atoms involved in its chemical composition. So that's why we say compounds are pure substance too. Okay. But like what is the proper definition of compound? Let's try to understand that. Substance composed of two or more elements chemically combined with one another in a fixed proportion. In a fixed proportion. I repeat, compounds or a compound is nothing but a substance which is composed of two or more elements which are chemically combined with one another. Okay. So students, try to understand, while defining pure substance, what did we say? We say that pure substance is consist of single type of substance which are similar, or they are identical in all senses, be it their physical properties, be it their chemical properties. Okay, they all are same. I hope you all are able to remember the example which I gave you. Suppose this is what is your iron rod. Okay, so we are going to stick with the same example just to recall whatever we have covered. So iron rod has these what? Atoms, right? These are all atoms which are made up of what? Iron. So they are all are iron, correct? So I consider the whole rod as what? A pure substance, because it is consist of one single type of atom which are having same properties, physical properties such as like melting point, boiling point, and chemical properties nothing but ability to, like one of the properties is what? Reactivity. So chemically and physically they are having same properties. Are you all agree on this? Did we cover this part? We did, right? So here where is the connection? Why did I revise this? Students, try to understand, I am saying that compounds are made up of two or more elements. But when we discuss, when we define pure substances, we say that pure substances are composed of one single type of, similar type of atoms or substances. Don't you think it's contradictory to our definition? But try to understand. Okay, we are not saying anything wrong, but we are going to understand step by step what is right. Okay, so definitely, let's suppose we are having element A, element B, they are getting combined chemically. They are getting combined chemically to give you what? Some substance which is nothing but compound. Okay, suppose A and B, these are two different elements, they are getting combined chemically. So try to understand what do you mean by chemically combined. So suppose if we are going to let me give example of such as I am having iron filings. Okay, I am having iron filings and I am having sulfur powder which is yellow in color. Okay, I am having sulfur powder. See, iron is a metal, sulfur is non-metal, and if we are going to take them in any random proportion, that becomes a mixture. That becomes a mixture. I'll draw here. Suppose this is what is a container. Okay, in this you have taken some iron fillings. Okay, and along with that you have taken what? Some sulfur powder. Okay, so I'll use the other color. Okay, this is what is sulfur powder, and this is iron. Okay, so iron solid. So what happens? If we are not going to apply, we are not going to set the mixture in any favorable conditions, such as either we are increasing the temperature, decreasing the temperature, or we are doing variables such as temperature or pressure are not in the favor of this reaction. That means we say that these two elements are going to stay with each other only like physically. Okay, there is no formation of chemical bond between them. So that's why we say it's a mixture and it's not a compound. But what if we are going to supply some heat to this mixture? It is now going to give you Fe plus S, you're going to give you ferrous sulfide, and that is now chemically combined with each other. Okay. Earlier you have just kept these two substances and there is we are not going to change any variable to make that reaction happen, to make that change happen. Okay, that's why we say they are physically bonded. There are no chemical bonds which they are experiencing. No. When we are allowing this reaction to happen chemically, chemical bonds are getting formed. Be it any form of matter. When we talk about compound, yes, they are going to get chemically combined. Try to understand. It's very, very, very important. Okay. So now I am having FeS. It is my compound. See, it is made up of what? Composed of two or more elements. How many elements do we have here? Iron and sulfur, two elements. Two or more elements. Here we are having two elements. They are chemically combined. We made that chemical change happen by heating these two reactants, by heating these two elements. Okay. So now they are chemically combined with each other, and this is how they are looking like. With a new substance is getting formed. When chemical change happens, we know that, we have studied about chemical changes. Okay, two or more reactants or elements are going to get combined with each other chemically to give you what? One new substance. And now this substance FeS, something I have written something FeS, is a compound. It has its name ferrous sulfide. Now whenever I am going to say ferrous sulfide, or wherever you are going to read the word ferrous sulfide, it has its fixed proportion FeS. If I am talking about fixed proportion by parts, what do I mean by that? It means one part of Fe is getting reacted with one part of sulfur to give you FeS. And this is nothing but what? Formation of compound. Iron sulfide will always look like this, FeS. No Fe2O3 or no Fe2S2 or no Fe3S3 or like that. So this composition is fixed. This composition is fixed, and that's why I am going to say yes, FeS is what? A compound. Are you all able to get it? If not, I am going to give you another example just to clarify your doubts. Students, I just want to give you one single example, example such as water. Water is our life, right? We drink it daily. So try to understand. I am saying that water is also compound, but how? Let's try to understand. How water looks, H2O. It is made up of hydrogen and oxygen. Water is made up of hydrogen and oxygen, that's what I said. Which means this hydrogen, which is a gas, right, is reacting with oxygen, which is again a gas, correct? So these two substances, these two pure substances, I am emphasizing on the word pure substances. Yes, they are pure. Okay. So we don't see any association of these elements with the other. They are pure. Correct. So hydrogen gas and oxygen gas, they are going to there is a chemical change which is going to happen when there is a supply of electricity. I am writing any electrical spark. So this is what is this favorable condition, student. Try to understand. Whenever a chemical reaction happens, okay, we need to supply any favorable condition to that chemical change to happen. So here, with the help of electricity, what is going to happen? Hydrogen and oxygen are going to get chemically combined. They are going to get chemically combined. Try to understand. Okay, there will be formation of bond between these two pure substances to get you what? Compound. To give you what? Compound. To form what? Compound. This is how a compound forms. It is made up of some constituents. These are its constituents. Constituents are nothing but what? What it is made up of? It is made up of these two constituents. Okay, hydrogen and oxygen, H2O. Now just focus on H2O. I'll write it here, H2O. This is your dihydrogen oxide. How many parts of hydrogen? 2 parts of hydrogen are reacting with how many parts of oxygen? Only 1 part of oxygen. Hydrogen gas 2 and oxygen is 1. So by parts, this is what is the ratio by parts of hydrogen and oxygen. 2 parts of hydrogen are going to get chemically combined with 1 part of oxygen, and that's how I'm going to get this compound, which is H2O, dihydrogen oxide, dihydrogen monoxide. Okay, so this is your water. This is what? Water. So if you are let me give you some example. If you are checking water sample, such as what? Tap water, river water, ocean water, sea water, raindrops. So these are different sorts of water. They all are having molecular formula which is in the fixed ratio, which is what? H2O. And that is what we have mentioned in the definition also. Substance composed of 2 or more elements chemically combined with another in a fixed proportion. Okay, you take any form of water, I mean you take any source of water. It is what? Chemically combined with the fixed ratio. By, if I am taking by parts, then it has to be 2:1. Let's try to understand the other ratio. Tell me hydrogen, like what mass of hydrogen. By mass ratio we are going to understand. So 2 is to, like how many oxygen atom? 1. So 2 is to 16. Correct? We need to find out the simplest ratio, which is what? 1 is to 8, right? 1 is to 8 of what? Hydrogen and oxygen. So this is the fixed ratio by mass. This is the fixed ratio of water by mass. Are you all able to understand? We have talked about 2 examples. Okay. So compound is a substance which is composed of 2 or more elements which are chemically combined with each other in a fixed ratio. Got it? So this is what, if you want to draw it, if you want to write it down, quickly do it. Done? Let's move ahead. So example, we have just seen water made up of hydrogen and oxygen elements, right? So we have seen hydrogen to oxygen by weight ratio is what? 1 is to 8, correct? Then again we are having what? The next example, such as what? Sodium chloride, which is nothing but your table salt, the salt which we use in our daily life. Okay. See, try to understand its chemical composition. It is made up of like 1 is to 1. By part ratio is what? 1 part of sodium is reacting with 1 part of what? Chlorine. Okay. So this is also considered as what? A compound. This is considered as a what? Compound. Okay. Again, the next property which we have to understand, that it is the smallest unit of compounds. Okay, so what is the smallest unit of compound? It is a molecule. How? I'll explain you. Suppose I have taken water. Okay. So these are some water molecules. Just now we have seen water is nothing but what? A compound. Okay, this is what is water, which we have taken in a beaker. Students, try to understand this. This is what is your water system, which has several molecules of water. I said molecules, which means consider H2O, 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 H2O. So if we'll see, each and every molecule in this system is consist of what? H2O. Okay, that is what is the chemical formula. Now can you tell me, if I am asking you, tell me the smallest unit in this water compound, definitely you are going to say, ma'am, this is what is H2O, which is a molecule and which is nothing but the smallest unit of this compound. Okay, try to understand. Let me give you another example. Suppose I am giving HCl. I am having HCl, that is hydrochloric acid. We have taken some amount of hydrochloric acid. Okay. So students, it is consist of what? Molecules of hydrochloric acid, and that's why we say it is the smallest unit of compound. Try to understand. Okay, quickly just draw it, this point along with this diagrams. This is for your understanding. If you are going to draw it after the class, you can quickly go through the diagrams and try to recall the concept which we have learned. Okay. All right. Let's move ahead. Yeah, this is what is some image. This is your salt, right? And that is water which we drink every day. So I have taken examples from our daily life so that we can relate it very quickly. Yeah. Can you all see it? So this is nothing but what we have taken, we have given some elements here. Oxygen, hydrogen, nitrogen, carbon. These are pure substances such as what? Element. Now focus here. I have shown you something like that as like what? NO, nitrogen oxide. Okay, it's a compound. One part of nitrogen, oxygen. Then moving ahead, we are having what? H2O. See, 2 hydrogen, 1 oxygen. H2O. That is how it looks chemically, basically. Okay, the arrangement. Then we are having NO2, nitrogen dioxide. 1 nitrogen, 2 oxygen. That's why di stands for 2. So nitrogen 1, 1 nitrogen, 2 oxygen. Then we are having carbon dioxide, 1 carbon, 2 oxygen. Okay, just have a look at these structural arrangements once again. So see what is showing that it is something like this. This is what your oxygen, it is bonded to 2 hydrogen. Okay, so this is what is your nitrogen, it is bonded to 2 atoms of what? Oxygen. Okay, just go through it once. Done? Let's move ahead. Now we are going to understand some properties of compounds with different examples. Okay. So here carbon dioxide can be prepared by various methods. Okay, carbon dioxide, we know that it is nothing but a gas which is present in environment. Correct. So carbon dioxide, like plants are going to inhale carbon dioxide and they are going to exhale O2. So carbon dioxide, we are quite familiar with carbon dioxide. So they have given the methods through which we can prepare carbon dioxide. First is what? By burning coke. Now what is a coke? Coke is nothing but what? It's amorphous allotrope of carbon. Try to understand. Carbon is nothing but a non-metal. Okay, it is a non-metal which is your element. Okay, which is again a pure substance. This is a pure substance. Okay, just to revise it, I have just drawn, okay, the link. Carbon, non-metal, which is element, which is pure substance. Okay, again I can say it's a matter. Alright, so try to understand. I have written something allotrope. Allotrope is nothing but different forms of one substance or different forms of one element. So we are having element carbon. So carbon has various forms. It has graphite, diamond, coal, and here is coke. Okay, so it has carbon. This coke has carbon. Burning of coke. Let me write it here. Carbon is getting burnt out. Of course, there is, if it is burning, we are having got oxygen. In the presence of oxygen, it is going to give you carbon dioxide. What it is giving you? Carbon dioxide. Okay. So students, it is one of the methods to prepare carbon dioxide. I hope you all are able to see this. I am just going to rewrite it, CO2. Is it clear for you all? Alright. So this is what is the first method. Then by heating limestone. Now limestone is nothing but what? CaCO3, calcium carbonate. By heating, we need to heat calcium carbonate. And what are the products? CaO, calcium oxide along with carbon dioxide. Okay. CaO and CO2. These are two products which we are going to get when we are going to heat limestone. This is what a limestone looks like. The marble, okay. So try to understand, which is present in chalk also, white substance, CaCO3. So my question to you is that students, when let's suppose if we are studying these two methods, preparation of carbon dioxide, observe this part, CO2, CO2. What I have written here, CO2. Did anywhere I have written C3O4, C5O6? No. What does it say? What does it indicate? It indicates that no matter through which method you prepare the compound, its chemical composition and also its chemical formula is going to remain the same. See, one part of carbon, two parts of oxygen. Same we are able to observe here, which we have obtained by heating limestone. This is your method number 1. This is your method number 2. So CO2 is your compound, which is one part of carbon is reacting with two parts of oxygen, which is fixed. Try to understand, fixed proportion ratio. That is where we make difference between elements and compounds, though they are pure substances. Okay, that is what my motto, to make you understand this point. Correct? So here CO2, I am writing it again. Now if I want to see its ratio by mass, by weight. Okay, so how? 12 is to 36. Okay, correct? Oops, 32. Okay, so that's how it becomes what? 3:8. The simple ratio becomes 3:8. Correct? So this is your ratio by mass. Got it? Again, try to understand, CaCO3 is also a compound. Ca, calcium, carbon, oxygen. Okay, so one element. We have seen definition of compound. It's a chemical combination of two or more elements. So we are having calcium, carbon, oxygen. Okay, three elements all together with its chemical formula CaCO3. Correct? Same goes with calcium oxide, CaO. Two elements are chemically combined to give you one fixed ratio, CaO. That is what its chemical formula, and that's why we say it's a chemical compound. Okay? Got it? Any confusion, any doubt? So if you want to draw it quickly, you can. Done? We get carbon dioxide in the same molecular formula. Thus now we have seen it, right? So CO2, which is made up of carbon and oxygen, these are two elements. We are having carbon and oxygen. Okay, they are pure substances here. Okay, they are elements which are what? Pure substances. Correct? Moving ahead. So they are having a fixed combination ratio which is 3:8. Correct? So yes. So this is this the same image which we have seen just now. Okay. Now try to understand some properties of compounds. See what it says. A chemical compound is formed as a result of a chemical change. Okay, whenever a chemical change happens, change as in what? A chemical, whenever is whenever chemical reaction happens, it's going to give you compound basically, right? Its proportion are entirely different from those of its constituent. Actually okay, so ignore the word proportion, it is what? Properties. Now again let's read it. A chemical compound is formed as a result of chemical change, and its properties are entirely different from those of its constituents. What happens? Try to understand here. We are having substance A or element A reacting with B, okay? It is also a substance or any other element. Both are going to react to give you a compound. Do you all agree with this? Chemical change happens, okay? Chemically they are going to get combined, okay? And we have seen it is a property of chemical change that when two or more substances are getting chemically combined, or if there is a chemical reaction which is happening, it is going to give you a new substance. A new substance gets formed. This is what is AB, which is a new substance, okay? This is an element 1, this is element 2, both are chemically combined to give you what? Compound, which is a totally new substance, it's a brand new substance. And what our next property says, that its properties are entirely different from those of its constituents. We are talking about compound. The compound which we have obtained here, or a new substance which we have obtained here, which is AB. It's a new substance which has its own set of properties, okay? And these properties are not same with these constituents or with these reactants from which it is made up of, okay? So A has its own set of property, B has its own set of property, and AB as a compound has its own set of properties. So try to understand, whenever a compound forms or it gets formed, generally or mostly whatever the property it has are not similar the way these reactants have, okay? So there is differences in their properties, okay? Quickly we are going to understand what does it mean exactly with the help of example. Students, here we have taken sulfur. This is how sulfur looks like. I hope you all are able to see it very clearly. We are having iron fillings. These are blackish. This is yellow. And we have taken mixture of sulfur and iron filings. Okay. So can you see, in a bowl we have taken it. It's a physically. So here is the term which I was talking about. Which what? They are physically combined. Okay. No new substance had formed. No reaction had there is no reaction which is taking place. It's just two substances are staying with each other. That's it, and that's why the word physically combined. But when suppose I have taken little amount of this mixture, I have used the word mixture. If I am taking some little amount of this mixture in a test tube, okay, this is what is a test tube, and there is a supply of heat. If there is supply of heat, see, this is going to give you some different substance. Why? Because what is happening? Chemical reaction is going on. Now I can say the product which we are getting here, it is, let me write it quickly. It's chemically combined. Initially the same substances were staying just together without the formation of bond or without any chemical change, and that's why we say it's a mixture, correct? But now when the substances are undergoing any chemical change, now whatever we are getting, okay, tell me the product, what must be the product here? If we are having sulfur, we are having iron, and now they are reacting together. So what is the product? FeS. Okay. So this is what is a new substance, that is AB, that is FeS. It's a new substance. So whatever is the property this product has, they are like completely different from the properties which sulfur and iron has. Okay, that is what is next property of our compounds. Okay, two or more elements are going to react with each other to give you a compound which is a brand new substance. Now this substance is having its own properties which are unlike to their constituents. Followed? Understood? Okay. If you want to make a note of this, you can quickly, just a general representation. Next property, what it says, properties of compounds are different from that of the constituent elements. We'll try to understand with this one example. The example is the same. By mixing iron fillings and sulfur powder, we get a mixture whose properties are the same as those of its constituents. Here what happens, they are talking about this case 1, this situation is situation number 1, this is situation number 2. These two substances, sulfur and iron fillings, are physically combined. Okay, so definitely they are going to retain their properties because it is a mixture of a sulfur and iron fillings. Okay, they are not going to change their identity or properties. But when the mixture is heated strongly, okay, when the mixture is heated strongly, a chemical reaction occurs and a new compound called iron sulfate is going to form. Okay, this is what is happening here. It is a new substance which has its own set of property. Are you all able to follow till here? Let's move ahead. Next property is that, okay, let me give one small example. Again, we are having hydrogen is reacting with oxygen. Okay, hydrogen is reacting with oxygen, going to give you what? Water. Hydrogen is a gas, oxygen is gas too. Okay, and this is what is your compound which has its own set of property. How? Try to understand. Hydrogen is what? It's combustible in nature. Okay, it undergoes combustion, whereas oxygen supports, or I can write supporter of the process combustion. It helps for combustion to happen. Okay, it helps combustion to happen. That's why we say oxygen is a supporter of combustion, and hydrogen can burn with a pop sound. It can get combust. Okay, so these are two different properties of these two different elements. Again, I would like to mention its physical state, such as gaseous state. Here it's gaseous state. Okay, so these are two properties basically. Now these two elements are going to get combined with each other chemically to form water, which is your compound, which is a brand new substance. Now try to understand. Water, it is in state liquid. We got a new set of property. Water, which we have got after the reaction of hydrogen and oxygen, it is a liquid, whereas these were gases. Okay, that is point number 1. Second is that, see, hydrogen is combustible, oxygen is a good supporter of combustion, but do we observe that water either combustible or it supports the combustion? No, right? In fact, what it does, it extinguishes the fire, right? So it's like if you see property wise, it's completely opposite. Okay, and that's why we say the compound or the new substance which we obtain when two or more substances are reacting with each other, it has its own set of property, and these properties are definitely not going to be the way hydrogen or oxygen has. Followed? Quickly make a note of this. This is second example after FES. Hydrogen, oxygen giving you H2O. H2O is compound which is like it extinguishes fire and which is liquid in state. Okay, whereas hydrogen, which is combustible and it is a gaseous substance or gaseous element, and your oxygen is its supporter of combustion, and again it's present in gaseous state. Got it? Is there any confusion? Is there any doubt? We have seen two examples to explain this property. The properties of like suppose any compound are completely different from its constituents. Done? Okay then. So yeah, this is what is the next property of compound which we are going to cover in the next session. Okay, so far we have covered what compounds are, okay, and what their like how do we define compound. We have seen few example such as formation of water, formation of FES, and we have just deal with one of the properties. We are left with some properties and soon we are going to cover all of them. Okay, that was all about today's students. We are going to continue this session. Okay, so until we meet next time, till then, take care, keep studying.